Hello friends. So now I am going to learn and we are going to learn today. The topic is insulator, conductor, semiconductor, and I am Meenu Yadav. So let's start our topic without any delay. So here is our contents. Contents are very simple: conductor, insulator and semiconductor. So what is the conductor? Conductor means anything regarding to the conductivity. So the substances in which there is a large number of free electrons available are called conductors. And electrons are doing what these are regarding with the conductivity. The resistivity of a conductor or metal is 10 to raise to minus 6 ohm centimeter. The weak bond electrons behave like free electrons, and these electrons can freely move inside the substance but they cannot leave the substance. These electrons are responsible for the electronic conduction. All metals are conductors. Silver is very good conductor of electricity. Aluminium, coal, mercury, human body, alkali salts also conductors of electricity. So I also have provided a diagram. So this is the diagram of conductor, insulator and semiconductor. Insulator also known as dielectric. Here we can see the conductor. In the conductor, valence, this is the valence band. Here is the conduction band, and there is no forbidden gap. In the conductors there is no forbidden gap. Here we can see in the insulator there is a large forbidden gap, and here no forbidden gap. And in the semiconductor there is a bit forbidden gap, but it's less than, very less than insulators and some more than conductor. Okay, so let's see insulators. Insulators means these don't allow the passage of current from these, means these doesn't contact free electrons. Substances in which number of electrons is negligible are called insulator or non-conductor. The resistivity is 10 to power to 13 ohm centimeter. And the example of insulators are wood, ebonite, glass, silica, sulfur, this is mica, and sulfur, wax, etc. Here the valence band is completely filled and the conduction band is completely empty. So forbidden band and forbidden gap is of the order of 6 electron volt. It's not possible to carry an electron from the valence band, which is completely filled, to an empty conduction band, and by applying external energy to that electron by means of an applied field, because this energy is too small, so the conduction is impossible, and hence such materials are called insulators. Diamond is an insulator with forbidden gap of 7 electron volt. Diamond have forbidden gap of 7 electron volt. Okay, 1 electron volt is the amount of energy that would be imparted to an electron charge 1.6 into 10 to power minus 19 coulomb on being accelerated through a potential difference of 1 volt. So 1 electron volt is equal to 1.6 into 10 to power minus 19 into IV. I means, what is the meaning of I? Here is the meaning of the I is current, V is the voltage. Okay, so let's see the next one, and the next one is semiconductor. So semiconductor, we can see the word semiconductor. We are gonna to separate these two words. Semiconductor means this is a conductor, but this is semiconductor. The substances which allow conductance in some circumstances, not always. These are semiconductor. Substances whose conductivity lies in between or between that of conductors and insulators are called semiconductor. For example, silicon, germanium, carbon, selenium. The resistivity lies between 10 to power minus 13 ohm centimeter and 10 to power minus 6 ohm centimeter. The energy band diagram for semiconductor is shown, which I have shown you guys prior. Here the conduction and valence bands are separated by a gap of the order of 1 electron volt. Forbidden gap of silicon is 1.21 electron volt, and for the germanium is 0.785 electron volt at 0 Kelvin. At absolute zero, all the semiconductors are insulators, but at room temperature the conduction begins due to thermal energy, and hence they become semiconductors at high temperature. It is possible for some electrons in the valence bond of semiconductors to gain enough thermal energy to jump over the energy gap into the conduction band. The absence of electrons in the valence band is represented by a small circle called hole. The hole is semiconductors, therefore refers to the empty energy levels in an otherwise filled valence band. The probability of promotion of electrons from valence to conduction band increases exponentially with temperature and decrease also exponentially with the magnitude of the bond into the conduction band. They have behind an equal number of the empty states or holes near the top of the valence band. The valence band is now not completely full and can contribute to conduction. These empty states and holes act as if they were positively charged carriers. Here the number of electrons in the conduction band are equal to the number of holes in the valence band. And a pure semiconductor which is completely free from any impurity. If there is a pure semiconductor and we don't put any impurity in it, so it is called intense semiconductor. A small amount of impurity having 5 valence electrons like phosphorus or 3 valence electrons like boron or aluminum are added to this, then it's called extrinsic or p-type respectively. See solid state rectifier. This would be detailed in the solid state chapter. We have read this into 12th class. Okay, so now thank you for listening me so patiently, and tell me how informative was this, and what can I improve and how can I improve. So thank you, bye bye, see you soon with another very interesting topic. Thank you.